In this video, I want to be going over how to calculate the activation energy for a certain reaction. So first, an activation energy is the amount of energy that reactants need in order to proceed to their products. So amount of energy needed by reactants to form products. So if we were met with a reaction A plus B goes to C plus D. Now, if we were to see this line right here, this just means that this reaction can proceed in the forward direction and the reverse direction. So A and B can form together to make C and D can then turn around and form A plus B again. So this is called a reversible reaction. So how would we calculate the activation energy for this reaction? We can draw an energy diagram. This will be joules, where we can determine how much energy we need to put in order to run our reaction in either direction. So what if we were to start with A plus B up here and C plus D down here? These will be our reactants, and these will be our products. So one thing we need to keep in mind is the enthalpy of our reaction. So the difference between our reactants and our products is our delta H, which is not our activation energy. This is simply the enthalpy of a reaction, and the enthalpy of a reaction simply describes how much energy per mole is either put in or released when we run this reaction one time. So as we can see, we are releasing energy from this high energy point down to this low energy point when we run this reaction. This will be an exothermic reaction, meaning that delta H is negative, and we will be releasing energy when we go from the reactants to the products. Remember that if the delta H was positive, we would be putting in energy, and this would be an endothermic reaction where delta H is positive. So this is not to be confused with what activation energy is. So if we were to see something like this on our energy diagram, how can we calculate the activation energy? Well, we know that A plus B needs to release this much energy in order to proceed. But what we see now is that we need to not only release that much energy, but before we can run this reaction, we need to give A and B some energy to start off in order to overcome our activation energy barrier. So we can think of activation energy as a barrier, as in we need to overcome that much energy in order to proceed from the reactants to the products. So this amount of energy right here will be our activation energy. Now, what we can see is that for the forward direction, meaning we're going from our reactants on the left to our products on the right, our activation energy forward is this energy value right here in order to get to the top right there. That is our activation energy forward. Now, what happens if we want to run this reaction from C plus D, our products, to our reactants? Well, all we have to do is start from here and go all the way up to the top of this hump, and that will be our activation energy reverse. So running this reaction in the reverse direction. So a simple way to solve for activation energy, whether you're going in the forward or reverse direction, it is simply where your starting point is to the top of that energy hump. So if we want to run this in the forward direction, it would simply be from our starting point to the top. And if we want to run this in the reverse direction, it is our starting point to the top. That is our activation energy forward and reverse. And again, activation energy is the amount of energy needed from your starting point in order to run that reaction.